Hello, everybody. Can everybody hear me okay? Cool. All right. This is the session building the V2 Twitter API with GraphQL and OpenAPI. My name is Erik Cunningham. I'm a software engineer working at Twitter on the API platform.
Hi, I'm Emily Shih. I'm also a software engineer at Twitter working on the API platform.
So what we're going to be talking about today, we're going to cover a little bit of background on the Twitter API to set some context. We're going to get into what we've built for V2. Specifically, the core of the platform that we've built is kind of constructed out of GraphQL and OpenAPI. So we're going to be covering how we're using them and why and how they work together. We're going to cover how that's been going for us and what we're going to be doing next. We're going to have some time for Q&A at the end.
Great. So what is the Twitter API? Twitter is where the public conversation happens. People are tweeting constantly, and it's where many come to gather online. As a result, there's a lot of information, and therefore a lot of data available on the platform. Twitter data is valuable and public, which makes it a great resource for many different use cases. The idea behind exposing Twitter data is centered around the belief that the smartest people actually don't work at Twitter. By making these endpoints available to the public, we can maximize the good that Twitter data can do. The Twitter API provides a set of endpoints for developers to interact with that allow for easy programmatic retrieval of Twitter data. For example, you can search for all the tweets that someone's ever tweeted, find tweets by querying for their content, find users who have liked a specific tweet, and much more. The API also allows developers to do much of what they can do in the app: create and delete tweets, follow and unfollow users, and again, much more. As a result, our API is useful in a variety of ways. For example, businesses can see who's talking about their product and how they're feeling about it. Okay. Scientists can see how COVID and misinformation about it is spreading. And app developers like Block Party can build better apps to block bad actors on Twitter. Twitter has provided API access since 2008, which we currently know as the V11 endpoints. However, the external developer experience was less than ideal.
So the Twitter API, it's existed for a long time. For most of that time, it's been known as version 1.1, but that version doesn't really have a lot of meaning. It's changed in a lot of ways that probably could have been. There should have been minor version bumps, and even some ways that could have been major version bumps. Maintaining and operating the Twitter API has presented a lot of challenges. Our team had the opportunity to kind of take a fresh look at what it was and what it did and how it got implemented. And we decided that a new major version, V2, and a different approach to how we'd done it in the past was the way forward. So what were the problems that we were trying to fix with V11? At various points in its history, the 1.1 API has both served internal developers, like the official clients, the apps you use on your phone and the website, as well as external third-party developer users. There's a difference between the kind of feature lifecycle and the stability requirements between those two use cases. GraphQL was starting to become a more attractive interface for rapid Twitter client feature development. And at the same time, with the 1.1 API, Twitter teams had to own and maintain the entirety of an endpoint's API functionality. So a specific team had to handle monitoring and alerting, had to maintain a consistent interface between the API and the backend, including hosting the service, defining and writing all parts of the endpoint, which made it hard to both get started adding new functionality to the API and continuing to own it over time. And again, over time, keeping things consistent, making sure that features and changes worked in all the places that they needed to and showed up in all the places that they needed to were major challenges. And the external developer experience was starting to become poor. We needed a fresh design, an API that was specifically for external developers with better versioning guarantees, a consistent design, consistent data presentation, and consistent behavior. So we wanted to standardize, as part of this effort, the design of the API. Specifically, we want to identify resources and parameters and request bodies to make them look the same and act the same everywhere. We wanted better ergonomics, we wanted versions that matter, and we wanted the spec to be available, and much, much more. So what we ended up with is a simple view of the architecture that we built. And when we're thinking about the audiences that our team is working for, there's kind of two constituents. There's internal Twitter teams that wanted to add new things to the API, new routes or adding new resources or expansions and features on those those resources. But principally, like the external developers are also our users. These are the people who are using the API to add new features, build new tools, new apps, and using the public data to augment Twitter. So in service of these two audiences, we built a platform that has kind of two major components. I don't know if it's like going to sleep or what. We have a configuration. This is what the Twitter internal teams build. It's a declarative configuration that turns into GraphQL queries and an OpenAPI spec that we kind of assemble as part of a build process. And the second is a runtime, which is the server that actually like receives HTTP requests from the external world. Small set of services that handle those things, and that's kind of all the runtime functionality. So this is handling inbound requests, dealing with their validation, like handling the parameters and request bodies, translating those things into a GraphQL query, interpreting, like issuing that query to the GraphQL backend, getting a result back, and doing a rendering pass over that data for the external view. So the result of this is that we effectively have a REST API implemented in terms of a GraphQL schema. And the runtime platform is one piece of code that's doing all the response rendering, so we can standardize all of our views and make our endpoints more consistent. And GraphQL provides kind of our main interface to all of our Twitter backends, taking advantage of migration for our internal and first-party apps that was already well underway. So what does the platform config look like? This is the kind of declarative data that Twitter teams build. This is a simple view of it. But two of the major pieces of it are what we call resources and routes. So resources are our main, so teams define these things kind of separately from one another. So resources can be kind of defined in isolation, and then routes kind of use those resources. There's a little bit of code and static data that goes along with each one of these things. So resources are kind of our main nouns. They're usually keyed with an ID, and they consist of a collection of fields. So you can think about like a tweet. Tweet has an ID. Tweet has fields like text and author ID and date of creation, all that stuff. Routes are defined using these resources, either to return them in a response or to create or delete or modify them. And each resource is, because it's defined in isolation, each resource is rendered the same way regardless of which route is returning it. So the route configuration includes a GraphQL query. So it's kind of like the piece of GraphQL that kind of glues that route together where that data is coming from. And some code to define some required properties. So like a version, where the version, like what version a specific thing is live in, what team owns it. Provide some hooks for more customization. And a small piece of OpenAPI that includes the path, the parameter names, and stuff like that. All of these pieces get assembled together during the development process and made available for the platform to use in the runtime. And the result is that each route has a static GraphQL document, including a complete resource built out of the fields.
Cool. So why GraphQL? As Erik mentioned briefly earlier, separate from the Twitter API, Twitter is already starting to use GraphQL to enable access to Twitter data. Clients were able to easily access that data from backend services. As a result, GraphQL provided a way for us to have a unified backend for all surfaces of Twitter, including web, iOS, Android, and the public API. Ideally, GraphQL documents used by the front-end clients can also be shared by the Twitter API, though there is still some work to be done to make sure they are always compatible. Regardless, moving to GraphQL was a huge step for Twitter. Twitter front-end clients and the API had never shared a backend like this before. Having a unified GraphQL model also enabled us to define objects consistently across these surfaces. And more specifically for the API platform, GraphQL documents provided us with a way to stitch individual field fragments together to define these objects. For example, for a tweet object, we were able to define fields of a tweet as GraphQL fragments, as you can see here. You have the fragment for the author ID, the fragment for the created at time, the fragment for the tweet's ID, fragment for the text, et cetera, et cetera. And when those are assembled, you can see the fragment for the platform tweet on the side, which contains all those fields and more. This becomes the structure that is returned for any endpoint that returns a tweet. You can see an example of that here. Say an external developer is using two different endpoints, one the get tweets by ID endpoint and the other the recent search endpoint. Different tweets are retrieved by these two different endpoints, but these tweets are still the same in structure. Additionally, we would expect the same data to be available in the web and phone apps. GraphQL documents are also assembled for routes. In the example here, you see the GraphQL document for the get tweets by user ID endpoint, which returns a user's tweets when passed that user's ID. In green, you can see the GraphQL document name. In orange, you see the selection, which returns the user as selected by their user ID. In blue, you see the resources that are returned by the selections. This first section of blue is returning the selected user. In yellow, you see the relationship, which is defined on the resource. In this case, this returns the tweets of the user. The second section of blue is returning a tweet resource, and in red, you see the fields of the relationship resource that have been requested. In this case, they are tweet fields. This is where that same platform tweet that we just looked at gets used in the routes GraphQL query. Furthermore, the ability to piece together fragments is what allows us to adopt this selection and relationship structure for our get endpoints, which adds even more consistency and predictability to our API. The selection and relationship fragments are defined separately, as you can see here, and when these queries are assembled, we end up with one GraphQL document per route, as Erik mentioned earlier. Looking at the get tweets by user ID endpoint path, we can think of the user and ID as the selection, which tells us the user to select, and the tweets is the relationship, which returns the tweets of that selected user. What's also cool here is that the selection used for getting a user's tweets uses the same GraphQL query and other platform configuration code, and thus follows the same code path as the get user by ID endpoint. Additionally, if we were to look at the GraphQL for the get tweets of a list by ID endpoint, we would notice that the relationship fragment used to return the tweets of the list is very similar to the fragment used to return the tweets of the user.
So that's how we use GraphQL to implement the public API. The other major component is using OpenAPI. We started with the assumption, first of all, we needed a spec for the public API. We'd never had one before. And we want one for all the reasons that you usually want a spec. We want better integration with tools. We want better integration with testing frameworks. We want to be able to generate SDKs, documentation, all that good stuff. When we started building the platform, the spec was effectively manually written from scratch by the implementing teams. You could reuse parts that already existed, standard like adding a ref in your spec, but it was still very, very hands-on to create. And we're on a progression here. There's still some improvements that we can make to save our team some time, but our usage of API and how we use it to build the platform has come a long way. So what does that look like? Effectively, we use a few inputs to generate the public OpenAPI spec. We use the platform config, the same configuration that we're using to generate these queries and assemble all these resources we use to generate the spec. We have a lot of what we need just right there in the config. We have a schema for each resource. Each route knows which resources it's dealing with. And the specifications for standard platform features like field selection, the developer can tell us which fields they want out of a resource. And given that that comes from the platform config, we can automatically generate the spec for those parameters. And we have a standard response structure for all of our responses so that we know where in a response a resource needs to go. So that makes generating the schema a lot easier. Each route also has a little bit of OpenAPI YAML right there in the config. It ends up being a great structure for keeping track of all the stuff that you need to define a route. Path, parameters that are unique to that path. It's just a really good container, and we use it as part of the config. And then we've added on schema components for when we need something that we can't kind of derive from the configuration. because we do everything in Scala, these end up being a Scala DSL that kind of wraps JSON schema for the most part. An example would be like the schema for error responses. They're not part of the resource definition, like a tweet doesn't have its own error structure. So we have a schema component that a team adds onto that, written in Scala, that gets included as part of the spec. And if a route wants to reference these things effectively in that OpenAPI YAML, you can put a ref to something that doesn't exist in a fully fledged schema, but is part of one of these schema components defined in code. We detect that, produce the spec that it's referencing, and include it. Other good examples for where we use this are things like request bodies, which also, like, they aren't defined in terms of a resource. If you have like a put request that can take some different parameters, we have a schema component for that and include it in the spec. So why is this a good approach? Because of the standardization of resources and routes that the config provides, we're able to generate a lot of the OpenAPI spec, saving our team some time. Because the configuration ties resources and routes together already, we can automatically include all the parameters that we need for things like field selection and expansions. And then team working on an endpoint doesn't have to worry about those at all. They don't even have to know that they exist. We automatically regenerate a static spec when anything changes. This is handy for doing things like code reviews and looking at diffs. And teams can define additional OpenAPI schema components in code. And we use Scala for that because it makes it interoperable with a lot of other tooling that we have, a lot of testing frameworks and CI and all that good stuff. And we can use the compiler as a tool to help us make mistakes and make sure we're not skipping stuff that we need. And as a result of having this data and code available to the platform, we can use the spec as part of the platform at runtime. Request body validation for requests that have request bodies, so puts and posts, uses the same schema from the spec to do kind of an initial validation pass. And that's handy because the users of the spec, anybody that grabs the public spec, gets the same schema that we're using to do that validation. You can test it yourself. It will actually work in your mock server, and you will get the right behavior. The backends can also provide validation failures to us. That's not the only validation that we do, and we render them all the same way because we have that single runtime. But it's handy to be able to say, like, before we even issue the request back to GraphQL, we can do this initial validation pass using the same schema that we publish publicly. And we have some tools and resources that are built in tandem with the platform that take advantage of these things. We have an API playground that uses the spec and helps generate some simple request code, curls, and snippets of code that you can drop in. We generate SDKs. We're kind of early in this process, but we do generate SDKs from the spec in Java and TypeScript to help people get started. These tools use the public spec, and we'll have a little bit more to say about them in a minute. But the result is a platform that uses both GraphQL and OpenAPI as kind of fundamental components to reduce the work on our teams, to make it easier to build stuff and deliver to the platform, and make a better developer experience for end users.
Cool, but that's not all. The platform provides other features that are useful both for internal and external developers and across routes and resources. Some of these might be a little repetitive, but for Twitter teams, you get a single definition for a resource selection and relationship. These can be reused and are repeatable for different routes. We provide abstraction of resource and structure and definition away from Twitter teams. As a team building an endpoint, you don't have to know what a tweet looks like, only how you're going to use it. We also provide monitoring and alerting, which are generated and provided by default, so Twitter teams don't have to write their own. Visibility filtering is also built into the platform. This means that the platform will ensure that only the allowed resources are returned in response. For example, if someone has you blocked, you can't see their tweets and you won't get them back in your response. And as a result of the simple configuration process, endpoint development can be pretty easy when a GraphQL document exists. This makes it faster to add newer Twitter features, even ones that aren't available in v1.1, to the API platform. Our Spaces endpoints are an example of this. For external developers, Field selection is customizable and repeatable, thus allowing external developers to retrieve as much or as little data from the resources they want. Expansions are built into resources, which allow external developers to return additional relevant resources in the same response. For example, the author of a tweet can be expanded in a tweet resource as an additional user resource. Error handling and request and response formatting, as mentioned before, are handled uniformly across the platform, so external developers know what to expect. Really, this is a benefit for both, as Twitter teams don't have to worry about implementing them either. And finally, versioning allows us to quickly and easily release new features to external developers. And there's probably more.
So how did this work out for us? How did we do? We have in the dozens of endpoints. We're just thinking, I don't actually have an exact count right now how many endpoints we have. We're launching stuff all the time, covering just about all, but not all of the 1.1 functionality. But specifically, we've seen faster creation of endpoints and faster adoption of new Twitter features in the API than we've seen in a long, long time. But the real question is whether or not we solved all the problems that we wanted to fix when we set out working on V2. So back to the original 3 problems that we identified. The V2 API only serves external developers. The adoption of GraphQL backends provides internal teams with a different tool to get data. They can use the GraphQL natively without needing to use the V2 API. That means we could focus more specifically on the needs of external developers and give them a more consistent experience. The platform, so there's a check on number 1. The platform handles a lot of common features across endpoints. The most straightforward case, a Twitter team can simply just kind of plug in a GraphQL document or operation and have a functioning endpoint in very little time. As mentioned before, the platform provides a variety of tools to help teams launch and maintain their endpoints throughout their life cycle. So I think we did a good job at helping our teams bring things to the API. And since the platform handles endpoints uniformly, external developers get a more consistent user experience. And I think that external developer experience is greatly improved from the 1.1 feature set. So ultimately, we were able to use GraphQL. We were able to use OpenAPI kind of as fundamental pieces together to build the public API platform and create a better V2 for experience for everyone. That's both internal, it's external, and hopefully some of you have actually used it as well. That'd be cool.
Yeah, so lastly, to plug the developer platform, if you'd like to find out more, get signed up, you can do so at developer.twitter.com. Links to the developer playground and Twitter Dev GitHub, as Erik showed us earlier, can also be found there. We're excited to see what you do with the power of the Twitter V2 API. Also tomorrow, our fellow tweep, Daniele, will be giving the keynote presentation tomorrow, and he'll talk more about what you can do with a lot of these tools and how easy it is to get started.
We'll see you there, and we're happy to take any questions you might have. Yes?
Thanks for your presentation. So how do you handle, say, or how do you detect and handle, say, potential breaking changes?
We have a few tools. Do you want to handle this one? Okay. So the question is, how do we handle breaking changes? The easy answer is that we haven't had to deal with kind of a fundamentally breaking change. We haven't had a back-end team that's told us, some piece of data that we depend on critically is changing in its structure in some way that we wouldn't be able to adapt. But we have had lots of changes between the backends, the GraphQL schema, and our front end, and we're able to handle a lot of those because of the layer in between. Effectively, we can reinterpret and kind of reorganize GraphQL results via the configuration. So we have some hooks. I said it's a declarative configuration. It's not 100% declarative. We do have hooks for code to be able to change things if we need it. So, for example, a team could, add a new field as a replacement for another one. We can move to adopt that new field in a non-breaking way, and then they could deprecate the old field. And a lot of that would be seamless to our external developers. but we have not had to deal with like a hard break, mostly because of the resources that we are dealing with. They're pretty long-lived and they're pretty stable, like tweets and users and those kinds of things. They don't change a lot in like gross structure. So we haven't had to deal with, I don't know, like a major structural change. But if we have to, this is version 2, we could always go to a version 3. We haven't really jumped off that cliff yet, but at some point or another it might come. I hope that answers your question. Yes.
So does your external customers see the GraphQL APIs directly, or it's only the front end is always REST?
The front end is always REST APIs. Yeah, the GraphQL interface is kind of purely for our internal teams to use kind of directly, and we are one of those internal teams that we kind of turn it into the external REST interface for our external developers. On the right here.
What's the traffic like to your API? Like,
What's the traffic like?
what's the traffic, overall API traffic? Is it like millions or?
It's in the thousands of requests per second, I want to say. Thousands of requests per second. Kind of broken out. It varies by endpoint, definitely. On the left over here.
Yeah, a follow-up question to that one that you mentioned app from GraphQL. Why not GraphQL directly to the customer?
Sure, yeah. We built the platform, I think, to have all those benefits that we mentioned in the talk. I think by being more opinionated that way, we can kind of control like what features are exposed to the external customer. Additionally, like because the GraphQL backend is shared across all these like surfaces of Twitter, it's like we don't own that GraphQL, and therefore like there's some like massaging of that to make it like in the form that we want to external customers.
I think there's also an argument for stability in the REST API that kind of isn't delivered in GraphQL. Teams want to turn things on and off because of how it's used in the like first-party clients, and so we wanted to provide a different lifecycle in the external developer API than what would have come across through GraphQL. Yes, on the right. We haven't announced anything. Old version is still up and running.
Things like deprecation policy, like in general.
In general, I don't know if we have a published one. Do you mean for the 1.1 APIs? Yeah. We haven't made any changes to that, and we haven't announced anything about the future of 1.1.
That's a great question. Yeah, I think ultimately, I think that'll really be the forcing function when we finish the parity with 1.1 endpoints, and then we can shut that all down.
Yeah. I mean, it's new features. Honestly, the 1.1 API has been missing a lot of things for a lot of years. Even basic stuff that people consider pretty fundamental to tweets isn't available in 1.1. Like polls are a good example. You can't get poll data in the 1.1 API. You can get it in the V2 API. And the teams that are working that maintain those 1.1 APIs, like the overhead to add that to 1.1, it might not seem like a big lift just to add some more stuff on the tweet response. It's actually a pretty significant undertaking for those teams to take that on and maintain it. And because that responsibility was shared across so many different things, there are many things that could return a tweet with a poll in it. All of those teams would need to make those changes, and all of them would need to be kept in sync. And so the overhead to actually like add new stuff to the 1.1 API, it just became harder and harder to do. And so, we think that like given this like unified resource structure that includes those new features, they're automatically included every time anybody wants to return a tweet, and they always work the same way. It makes it much easier to keep that feature parity with like the stuff that you actually see in the apps. And I think that's going to be the motivator for people to, adopt the V2 stuff as time goes on.
Yeah.
So you mentioned you have different teams, internal teams that consume the GraphQL endpoint. What about how do you handle, let's say, different teams having different schema needs? Yeah, you knew that was coming. So.
Yeah. It's a challenge because not everybody is thinking about how their data is going to show up in the API when they're constructing a feature. We meet and talk about it, and like we try to hash it out, and that's really the answer. Is like we have a internal API team, the core API team that is principally responsible for the GraphQL backend, as well as it has its own kind of main interface to this whole galaxy of microservices. And they kind of provide guidelines for how to model data in a way that is usable both by the client engineers as well as us. And we sit on that group and advocate for people doing stuff that makes our job a little bit easier to bring it to the API. It doesn't always work out 100% of the time, but at least, it's a negotiation between the requirements and like they want to just bring stuff to the client as fast as possible. We want to make sure that it's a reasonable and consistent experience in the API. Sometimes those two things don't line up exactly, and we just got to work it out. We at time? I think we're at time.
Thank you.
Thanks, everybody.